Hello everyone. In this video, we will see the second function related to dynamic memory allocation is calloc function. As the name given, C stands for contiguous and alloc stands for allocation. That is contiguous allocation. So just like malloc function, this function is also used to allocate memory dynamically, that is at the time of program execution when the required memory is not fixed. So here depend on the number of blocks user wants and the size of bytes given by the user, this function allocates the n number of memory block in the memory. The main difference between malloc and calloc is malloc function creates single block of memory of given bytes, whereas calloc function creates n number of blocks. So malloc creates only single block and calloc creates multiple blocks. Suppose user wants 5 blocks of memory and each block should hold 20 bytes of memory. Then by using malloc function, 5 blocks which holds 20 bytes each will be allocated in the memory. That is, total of 100 bytes will be reserved in the memory. And it also returns the address of first byte of first block through the pointer variable. Now we will see the syntax of calloc function, which is already declared in stdlib.h, that is header file. It is almost similar to malloc function. Malloc function takes only one argument, that is for size in bytes, whereas calloc takes two arguments, one for number of blocks and second is for size in bytes. This is the syntax of calloc function, which is already present in stdlib.h file. That is void pointer, then calloc, and in bracket first argument is for number of block we want in memory and second is for size in bytes for each block. So here size means how many bytes of each block we want to allocate in memory. Calloc is the name of function and the return type is void pointer, which returns address of first byte of first block. So if you see the return type, instead of using data types like int, float, the return type is void. So why the return type void is used? So basically void is a generic data type and it can be converted in any data type later by using typecasting method. The return type void is used because we don't know at the starting calloc function is used for which particular data type. So that's why it is used with return type void. Now we will see how we can use calloc function. This is the syntax of using calloc function. So here ptr is a pointer variable which is used to save the address of first byte of first memory block. So suppose we have created 10 bytes of blocks, then ptr will hold the address of first byte of first memory block. Calloc is the name of function and in bracket n is the number of blocks we want in the memory and size is the number of bytes for each block we want to allocate. So this calloc returns the value void but to store this value into pointer variable ptr, it has to be converted into appropriate data type. So depend on data type of ptr, we have to mention the data type which is used before the calloc function. So if pointer variable ptr is integer, then data type star should be int star. So this will convert the value returned by calloc function which is in void type into integer data type. We will see one example based on this. So here we have declared one pointer variable of type integer and one normal integer variable n. Then by using calloc function, we will allocate n number of blocks in memory. So we have written n comma 2 in the brackets. That means calloc will allocate 5 blocks. Each block will reserve 2 bytes of block in memory. So total 10 bytes. So here calloc will return 10 bytes which is of type void. So our pointer variable is of type integer. So that value returned by calloc function which is of type void should be converted into integer. So that's why we have used int star in brackets. This will convert the void type written by the calloc function into int type. Now this int value will be saved in variable ptr. So now ptr will hold the starting address of first memory block, but the size of integer data type is depend on compiler. Means few compiler takes 2 bytes for one integer, few takes 4 bytes for one integer. So how much bytes required for integer is depend on compiler. So to overcome this problem, instead of declaring size, we can use size of function to get the exact memory needed by the particular data type. So the same example we can write it in this way. So size of function gives size required by the integer no matter which compiler we are using. So suppose compiler takes 2 bytes for each integer, then size of int will give the result 2. And suppose compiler takes 4 bytes for each integer, then size of int will give the result 4.